It's a minute past noon on the East Coast. It looks like we have all of our speakers, so we'll go ahead and get started today. Today we wanted to talk about OpenSea's new release, Seaport. We have Zero Age from OpenSea on the call to talk about that, and then we also have the Spearbit team here who competed in the Code Arena contest to talk about their experience there and share some of their insights on that. So without further ado, I'll pass it over to Moise, who's going to be hosting this conversation and handling the Q&A.
Thanks, Jake. Welcome everyone to this conversation between OpenSea and Spearbit. As Jake mentioned, this is going to be a really exciting Twitter space as we discuss what some are calling the Super Bowl of audits, and taking us behind the scenes to get the inner workings firsthand from both OpenSea and the Spearbit team. Hopefully for our audience today, you'll be able to get some helpful insights when it comes to security and the inner workings of Web3. And in general, have this great sit down with these amazing group of guests. So with that being said, we're going to do a round of intros. Let's start with Zero Age from OpenSea, and then we can go through the Spearbit team as well.
Hey everybody, I'm Zero Age, head of protocol development at OpenSea, and proud to say I am one of the contributors to Seaport repo. Thanks for all being here.
Thanks, Zero Age. Let's start with Axic, and then we can go through the rest of the Spearbit as well.
Yeah, hey everyone. My name is Alex otherwise, and I've been working quite a few years on the Solidity compiler as well as the language, and next to that on EVM research, and lately have grown an interest in the security aspects of this. That's how I ended up looking at some of the code, including Seaport.
Yeah, I could go next. I'm Hari. I also worked on the Solidity compiler for the last 2 years, but otherwise my background is as a mathematician, and lately I'm helping out Spearbit. Yeah, that's it. Gerard?
Yeah, my name is Gerard Persoon. In my whole life working in the technical part of IT, and I've created a Solidity course for the Hague Technical University some time ago. And then after that, I started competing in the Code Arena audits. And yeah, the last about half year, I'm working with Spearbit doing lots of different audits. So yeah, that's about me. Leo?
Wonderful. And let's introduce as well our special guests, Sawmon and Natalie, that took second place in the C4 competition. Would you like to give yourselves a quick intro?
Hi, everyone. So this is Sawmon and Natalie. We got into this competition because I think mostly because I've been looking at Zero Age's work. And since this contest was really involved in terms of low-level EVM stuff, so that was kind of intriguing to participate. Thank you.
Thank you. Well, the format for today's discussion is we got some questions outlined for our guests, and then towards the end, we will hopefully have some time for questions from the audience. So take some notes and reserve those questions till then. I know this conversation might take some loops and turns, but for the better. So with that being said, our first question here is for Zero Age, and I think it's going to just kind of set the tempo for this as kind of send the precedent for how did you as a team with OpenSea get the idea for going through with submitting a bounty on C4 and kind of kicking off this?
Absolutely. So work on Seaport started beginning of this year. We knew that we wanted a new marketplace, but that's no trivial undertaking. And we spent months getting everything all ironed out from a high level, making sure that the architecture was sound and the general approach had all of the features that we would need and that we felt that others in the space could also use. Wrote a lot of tests. If anyone has poked around in the Seaport repo, we've got a full suite of hard hat tests with full code coverage. And then we also have another suite of Foundry tests to handle the more in-depth fuzzing and round out the test suite. We also had multiple auditors. I see a couple familiar faces in the list of guests here. Both OpenZeppelin and Trail of Bits audited the code. And all of those steps we knew were really important. But at the end of the day, nothing quite gives you the confidence that something is production ready like widespread review from experts. Code Arena was the perfect fit for that, with an entire impressive suite of reviewers, wardens in Code Arena's parlance, that were just ready to dive right in and tear the repo apart. So we got it to a place where we were feeling pretty good about it going into the competition. And then Spearbit and Sawmon showed up, and many others. And I'm sure we'll get into some of the details on the things that were the findings and the remediation therein.
Yeah, I think that really introduced, for at least the security researchers side, like the functionality of Seaport and seeing the submission for the bounty got a lot of attention right away. And segueing this to kind of introducing Spearbit and how that team came together, kind of what's for the Spearbit side, Alex, Hari, Gerard, what kind of sparked your interest in pretty much going head on into diving into this code base and trying to, as Zero had mentioned, rip and tear apart what they had assembled?
Yeah, I'm gonna take that. Yeah, I think mostly it was just curiosity. Like, OpenSea was one of the biggest protocols on the Ethereum mainnet. You could always see OpenSea on top of the number one gas Kessler contract in Etherscan. So when OpenSea came with a new contract, of course, like, we were curious, and then this Code Arena competition was like an excuse to like actually look at the code and review it. So the team was actually consisting of like Alex, me, Gerard, and also Leo from Ethereum Foundation, and also the Solidity team. And yeah, it was just like having some fun. That's it.
Yeah, I would maybe extend that with, we did had a look at the code, and obviously it was quite a unconventional piece with a lot of assembly. Even at the first look, it looked like, okay, it does have a lot of assembly. It should be right up our alley, or at least it should be something challenging our knowledge of DVM and Solidity. And I suppose, when we actually got into looking at it, it was even more complex than we anticipated. But yeah, I would say it was a big part of taking up the challenge of this level of code complexity.
Yes, and with that complexity does come risk. So, Zero Age, from your perspective, going into this, were there key risks that you were already aware of? I know you had mentioned there were prior audits that had taken place, and I'm sure there were issues and vulnerabilities that were found and probably caught through that. But was there anything that you had knowledge of and were kind of anticipating going into the competition? And maybe even expand that into what were some of the surprises that came through it?
Absolutely. So, as everyone is pretty well aware, assembly code is something you really only reach for when you need it. And I would contend that in most cases, you don't need it. We're lucky to have a few of the Solidity core compiler devs here on the chat, and they can attest to all of the hard work that's gone into making Solidity really safe and abstracting away a lot of those sharp edges that you'll run into when you're dealing with the EVM at a low level. That being said, OpenSea's marketplace prior to Seaport, Wyvern, was not only squarely at the top of the gas guzzlers, but was designed in an era where gas prices were not as much of a concern and had a lot of low-hanging fruit. I would actually argue that many of the core optimizations of Seaport, and indeed the majority of the key findings, didn't actually involve assembly code. A lot of the optimizations were more structural and just doing things like avoiding needing to deploy a user proxy before you could make listings and offers, or avoiding expensive external calls and superfluous storage reads and writes and things like that, which are very much something you can accomplish without ever needing to reach for low-level code. But from there, we really wanted to push it to its most the strongest way that we could ensure that this marketplace was something that would scale, that would be usable by as many different projects and marketplaces as possible, and deliver the most value to OpenSea users as well, was to make it as gas efficient as possible. And indeed, there's pretty compelling evidence that it's helped bring gas prices down across the board because there's less congestion to begin. So I think that given that we made the decision to use this assembly code, it also had an unintended benefit here that Hari really alluded to, that the fact that this had a lot of assembly actually got more eyes on the code, in my opinion, than we might have had otherwise. It became an interesting exercise to read it, learn it, understand how it was working, and some of the tricks that were being employed. But it did mean that regardless of whether or not we were using assembly, we knew that we needed to get as many eyes as possible on this, that it was really mission critical production code that was going to be effectively moving NFTs with a lot of value at stake. And so regardless of that piece, it was really important to get a lot of eyes on it, and talented eyes. Luckily for us, the Venn diagram of good auditors that understand low-level code and Solidity compiler devs is a little circle inside of a bigger circle. So that was amazing. And then coming out of left field was Sawmon with a fantastic showing in the competition.
With that complexity, I think the Spearbit team and Sawmon, and let's start with Gerard. Can you give your perspective as well on kind of what were maybe some of the surprises from looking at the assembly and the lower level code? Can you give your perspective on what maybe surprised you within Seaport when first looking at it? And let's start with Gerard and get Alex's take and Sawmon as well.
Actually, one of the first things that I was diving into was in the basic order fulfiller part, which takes a lot of has a lot of assembly. and I started looking into it and found something strange, which almost was a bug. But in the end, there was a little piece of Solidity that actually corrected the issue. So there wasn't an issue. But if that last piece had been translated to assembly without any additional checks, then there would indeed have been a high-risk bug. So in the end, there are some extra checks were added in the final code. But yeah, that was an interesting area to look into and to research and also improve my understanding of all the assembly code and everything.
Yeah, to elaborate a little bit on that, of course, at a higher level, Solidity performs a lot of checks to make sure that if you're passing in a uint that's not a full uint 256 or any type that's not a full word, it'll ensure that it's indeed doesn't overflow into a larger value, right? It'll mask the higher bits. Same with enums, which in the basic order case, there is an item type that specifies if you're dealing with native tokens, ERC20, 721, 1155, and then one of the key optimizations that's applied throughout the assembly is branchless logic. So if you use a conditional, that translates into a jump I opcode, and those add appreciable overhead if you have a number of them. Instead, if you can actually operate on the values and regardless of which path you take, you're going to perform the same operations, then you can often do things much more cheaply. But you can see how those two things can conflict with one another if you are expecting, I'm going to have one of these 5 possible enum values or 6 possible enum values. And so I can set up this branchless logic determining, is this an ERC 721 to ERC 20? Is this native token to ERC 1155? And then if you step outside the safe range of enums, then you can find yourself in hot water. But yes, I also would just, I'll mention to everyone here that Gerard is actually he's a unit when it comes to branchless logic and deserves the credit for some of the coolest branchless logic, which is found in criteria resolution, dealing with resolving Merkle proofs. Definitely worth checking.
Yeah, that was a nice improvement indeed.
Sawmon, go ahead, Gerard. Go ahead.
Yeah, was interesting. There was a piece of logic where functions were rearranged via assembly to be able to take in different kind of structs, so to optimize the code. And there I also find a small optimization which did not end up in the final code. Well, that was interesting to look into that and to see how that code could be improved even a little bit further with a bit further. So that's it.
Sawmon or Alex have anything to add as far as any surprises?
Yeah, I mean, I was going to talk about the same topic initially because it seems like this was the biggest one, right? I mean, this particular example is about what Zero Age mentioned about enums, cleanup of enums, and the cleanup of a variable can happen after you at the end of a Solidity function, and if you modify that. Or at the end of the function, or if you pass it to another function on the input side. And in this particular case, we had like assembly blocks, and in between those assembly blocks, there was a call somewhere else. And in fact, that call to somewhere else would have triggered the cleanup and the validation. But this particular case also then directed us into looking into other similar cases where, is there anything else where safety relies on cleanup being done on the Solidity side? And actually, there are many more such cases in the code. And if you look at isolation and the assembly stuff, or just helper functions, many of them would contain vulnerabilities on their own. But actually, they are either by high-level Solidity constructs or by specific checks elsewhere. They would have some safety checks to ensure that they're fine. That being said, there's so many levels of helpers that it is quite a challenge to build up a mental model about the entire code and where are checks enforced for certain parts, because it may not be like the one level above, it may be like 3 or 4 levels above the code you're looking at. So I would say that this definitely is quite a challenge, and it also has the inherent risk that if you use such helpers elsewhere and you're not aware of these requirements the given helper has, then you're going to run into issues. One example of that is there are a bunch of helpers to do low-level transfers. One of them is the ERC 1155 batch transfer. And these functions try to optimize memory usage by clubbering existing memory fields. And a good example for this are the special memory positions, the first 5 memory positions, which are used for specific reasons by the compiler. And these functions make use of those fields. And some of these actually store the value and then restore it. So you are able to use these helpers back and forth multiple times. One exception is the batch transfer, which actually doesn't do the restoration at the end. So the compiler state will be in an unknown state. So it's not something you want to use multiple times. It can only be used once, and then you terminate the execution. So there are many such cases, which was, I would say, quite a back and forth, making sure that, these are only used in such cases that they're safe to use. And all of these are motivated really by gas savings, either gas savings through memory or gas savings through not applying the same checks multiple times over. And maybe I would, on the same note, mention one last thing, which I found kind of confusing in the sense that it adds some overhead. That a lot of these fields, on one side, it was nice that a lot of these assembly statements changing certain memory fields had a constant specified somewhere. So you only looked at, instead of numbers, you looked at constant names. But the constants are mostly collected in a single file. So either if you have a good IDE, which resolves all of these, if you don't have a good IDE, then it is quite complex tracking it, especially that many of these would have the same value and some of them would have been reused. So there were some findings even around that case. Yeah, I could go on longer, regarding many other things, but I'm going to do a pause now.
Yeah, on the note of constants, this was a really an interesting one, because on one hand, if you are really fluent in, okay, I know exactly what the offsets are going to be for all of the compiler constants, I have a really solid working knowledge of what the structs in question are, the way that ABI encoding works for how we're going to assemble those structs into an array of Seaport orders, things like that, then inlining those constants probably makes the most sense. It's less context switching. But we made the decision to actually blow away basically every literal constant and replace it with named constants. And while it does require some jumping around, I think it's actually been really helpful and useful for people that don't have such a deep knowledge to be like, oh, okay, we're gonna go get the free memory pointer, and it says right here, mload from the free memory pointer slot, that kind of thing. Yeah, it's one of many controversial aspects of the Seaport codebase.
Yeah, introducing such a massive code base and this new functionality all at the same time, while being in kind of this pressure cooker of a 2 week competition, for a lot of us, and I mean, not for our guests maybe, but for a lot of us, this can kind of feel overwhelming or kind of would have a struggle to figure out where do you even start. So I would like to start with Sawmon, and then we can go to the Spearbit team and take us through. I know it's been, a couple months removed, but take us through where did you even start when taking a first look at this code base and kind of putting together an approach with kind of this finite timeline and all the externalities that are kind of making this complex. How did you go about making the most out of this time? And obviously, the results show what you were able to accomplish with this. But take us through that kind of beginning to end in the briefest amount of time as you can. But yeah, Sawmon, you want to start?
Yeah, thanks. So I guess the first thing that I did was I maybe quickly skimmed through the whole code base, and then the second step, the most logical thing for me was to create a diagram of all the different classes and contracts, and basically create the inheritance tree. So once I had that diagram and picture, I started bottom up. So basically from the very last grandchildren or something, and I analyzed those contracts first, then I worked my way up to the very top one, which was Seaport, or like consideration just under Seaport. And I guess like what everyone mentioned about constants and stuff like that, I think I found it useful, but one thing that Alex also mentioned, it's just the overhead is to also check every single constant and make sure all the values are calculated correctly. And then from that point on, basically for each contract, you have to go through each function, and since it's like mostly written in assembly, it takes a bit longer, but the whole process was kind of logical. And I guess once you have a good understanding of each contract on their own, then you have to start drawing the bigger picture of how things interact with each other, and then just like draw the bigger picture in your head. And two, I guess, also answering the first question that everyone was talking about, one thing that I found interesting about the Seaport was if you look at the code, there aren't that many storage slots that are being used. There are basically mainly 3 storage slots that are like private, and one is, for example, is for reentrancy guard, and then the other one is for counters, which used to be called nonce, and then the other one is like keeping tab of the order hashes of like if they're valid or not. So if you like look at the code, you'll see that it's really memory intensive. So most of the operations are done in the memory, if not on the stack, on the memory. So there are also lots of juggling around the memory, and like lots of gas saving to like kind of squeeze as much operation as you can in a smallest amount of memory without like memory expansion. So that's it.
Yeah, to elaborate on that particular point, I think that actually is one of the areas where assembly really shines. And this is obviously also why it can give the Solidity core devs an aneurysm to review this, because a lot of work has gone into keeping the Solidity compiler memory safe. And on the flip side of that, there are definite inefficiencies that come with that, particularly when you're dealing with big arrays of structs and modifying those structs into different types and reusing them in different contexts. So if one of the primary places you would reach for assembly is in memory management. If you do manual memory management, you're not going to get that much benefit from managing the stack. Not to mention, you probably need to be reaching for Huff or something even lower level than Yule to be manually managing the stack. And with storage, there are huge wins, but they don't require assembly at all. Memory is the sweet spot where I think that there are just fundamental limitations to taking a generic approach to keeping a memory safe environment that you can start to bend the rules a little. It does make code reuse way more dangerous. I strongly encourage anybody on this call to reach out to us if you're thinking about reusing portions of the Seaport code base, because as Alex insinuated earlier, it's dangerous to do so. There are definite assumptions in play. So, but I think it's an unusual thing when you have a single contract with a lot happening in memory. That's when you go for it.
Yeah, just expanding on the memory side, actually, a lot of the, one reason you want to optimize memory, because in Solidity, functions wouldn't necessarily free memory at all. If your function takes in a memory pointer and returns another one, and if it keeps operating on memory, growing the memory, that growth may not be freed, and so you end up with much larger memory use than you expect. However, I wasn't sure, about the memory savings this code has gotten, and I mean, I don't know if anybody actually checked it, whether it was worth it doing it like this just for the memory alone, but it uses two more tricks, which I think may be more significant. And for that, you may not even need to use assembly. Is that in a lot of the parts, when it operates on external data, it ensures that up until the last point, that data is passed down as marked as call data. So the functions, if you have a input which is not a value type, aka it's like a bytes or an array or a string, and that is marked as call data, then no memory operations are happening on that input up until the last point where you actually inspect that data. And this has been utilized by OpenSea as well, and in some cases, at the very leaf of this, even the call data inspection is done in assembly. And I think the main reason you would want to do that in assembly, if you want to have more specific rules and simplified rules on API decoding, and so you can save, some extra checks the compiler is adding, because the decoding logic in the compiler is much more generalized as opposed to what OpenSea has as a requirement. And to give an example, is that OpenSea expects a very strict ordering of how the API is encoded, while the compiler is able to handle maybe unconventional orderings. And to give an example there, you may have strings. So when you encode the API, you have like the fixed portion and then you have the dynamic portion. And if you have like two strings, for example, that is a pointer to the dynamic portion. Each of them is a pointer to the dynamic portion, and the generalized decoder is able to handle a case where you have gaps between them, or it can be overlapping. It can do a lot of things, OpenSea doesn't allow this. It has like a strict ordering. And if you do a decoding logic for that, that is obviously more simplified than what the compiler is doing. So I think this is the reason it has been done like so in OpenSea. And finally, I wanted to add, actually, this is what I wanted to start with, but yeah, I pretty much agree with what Sawmon and Natalie said. But there's one more trick you can look at in decomposing such a code base. If you look at, speaking about safety, since 0.8, every single arithmetic instruction is using checked arithmetics, aka safe math, which means the compiler inserts a lot of code to check for overflows, etc. And then there's the unchecked block to avoid that code. And so, in code bases where there are some assumptions and you believe that those assumptions can be fully fulfilled prior to getting into your code, you do use unchecked blocks to avoid that overhead. And that is the case in OpenSea. There are a lot of unchecked blocks. And when you encounter unchecked blocks, a good strategy is looking at them and see, what would happen if some of those values would overflow, and how you can trigger such an overflow. Or an underflow, or whichever way where you would get out of bounds. How do you achieve that? How do you craft inputs to have that happening? And obviously, for that, you need to go up the entire call chain and check, what is going on. And I think this has been quite fruitful in finding issues in OpenSea itself.
Yeah, that leads very nicely into. Do we want to discuss some of the findings from the code arena competition?
Yes, let's do it.
So I'll give a quick high level, and then let the finders get into some of the details. So one such instance that fell prey to this exact thing, and actually had there were a number of additional and really interesting areas of optimization and exploration that grew out of this, that I think, Hari, you would be really well suited to talk to, is partial fulfillment. So with Seaport, you can specify on the order type, I'm willing to take a partial fulfillment of this listing or offer. So every single item has its amount scaled down by a certain fraction. You provide a numerator and a denominator, and it scales everything down. And as long as everything is exactly scaled down with no remainder, no modulus, or modulus 0, then you're good to go. And then the order status gets updated with the new filled fraction. You get into trouble when you set very large numerators and denominators, 2 to the 118 over 2 to the 119, that kind of thing. In an unchecked block, we were, or maybe it was just casting, but very similar. You could overflow the partial fill fraction and then refill an order. So that's obviously breaks one of the core invariants of Seaport, where you should never be able to spend more than what's offered. Even though the terms are still the same, you still get what you're asking for. You're duplicating orders, in effect. There's also, and the fix was quite straightforward, but there's another component to this, which is you could construct malicious fractions that then become unfulfillable and effectively block an order from being fulfilled. And in those cases, to sort of work around that limitation, we came up in concert with Spearbit, an approach where we actually compute the greatest common divisor using the Euclidean algorithm, and scale as soon as you reach a situation where that filled fraction would overflow into it's a uint 120, so that you can pack it with 2 booleans and then 2 uint 120s into a single storage slot. as soon as you would trigger an overflow, then this Euclidean algorithm will run and attempt to find the greatest common divisor and scale down those fractions and update the filled amount. So it's sort of like if you are trying to perform some griefing or denial of service attack using a malicious fraction, then it's a recoverable state. And so I thought that one was very interesting. That was the finding that was discovered by a number of wardens and reviewers, and was a good one that had been in the code base from the earliest days. It's sometimes you get complacent when you're working on the really complicated parts of a code base. You can overlook the stuff that has been in there for a long time, and you just sort of assume that this is the easy stuff, but it's just as important to put it under as much scrutiny. Hari, you want to add any more color to that?
Yeah, that was a very fun bug to find. I mean, I could probably explain like how we ended up like finding this. Maybe that could give some context to like everyone listening. Yeah, so as Steroids explained, they're trying to like emulate some kind of like rational arithmetic. And typically, like if you want to like build a rational arithmetic library, you have to like deal with this GCD, like no matter what. Otherwise, you have this issue that if you try to like add two rational numbers, you have, I mean, the numbers A and B becomes bigger and bigger as you keep adding. So you have to at some point like scale it down. So when I looked at the code and there was no like GCD involved, that was already like suspicious. So the main issue that we were trying to look for was, okay, can you like grief it? What if you just keep scaling it, and what would happen in that case? But when we actually tried to like look carefully, there was a more serious issue, which was it wasn't just a griefing, it was also this truncation. So yeah, I think I would recommend like people to think about like these problems in terms of like invariance. Like, you know, if you're trying to solve this problem, there should be a GCD somewhere, and there is no GCD, so what is going on? Yeah, so that was a fun bug.
Yeah. By the way, the core findings from this Code Arena competition, there, at least from my perspective, there were 4 of them, and they're all in the Seaport repo under Seaport test findings. And I think this is a great pattern for anyone that goes through an audit and has findings. This was Dylan Keller's idea, and he put these tests together, and I think it's a really good one. The idea is that you have a test that you know that the test is going to trigger the finding, so you confirm that the finding is accurate and exploitable, and then you also have a test alongside it that all you need to do is flip a Boolean, like a flag, and then it will test that that particular finding has been addressed. So then what we could do is implement all these tests, confirm that the findings were exploitable, and then make a single targeted PR that just flips it and show that along with the patch, and keep a minimal diff for and have a PR you can point to saying, look, here's the PR that it was the test suite was passing because the flag was false. Then we made this single change, flipped the flag, and now the test suite is still passing because the invariance that it's checking for, the assertions it's making, show that the finding has been addressed. So I think it's a really good pattern that I would encourage anyone to employ, particularly for transparency and reproducibility. So the next finding that I thought was pretty interesting was on our criteria resolvers. In Seaport, you can specify for your item type to say this item uses a criteria. It has some criteria that needs to be met. Rather than a specific token ID, you give a Merkle root that then you supply a proof saying a certain token ID is in that root. And because a token ID is a single word, we had pushed the optimization a little too far and said, rather than hashing every leaf before we insert it into the Merkle root, let's just treat the token ID itself as the leaf. And that caused a number of issues, namely that you can resolve intermediate nodes in that tree as though they were token IDs, including the very roots. It's like if I have a hash 1 2 3 4 5 6 7 8, then I could use that and resolve it with a shorter proof than the intended proof length and get token ID 1 2 3 4 5 6 7 8. So by hashing every leaf, you then would have to have a pre-image of that hash in order to retrieve a token, which those are bigger problems or harder problems to solve as an attacker than finding an intermediate node. Any color that anybody wants to add to that particular finding? We can keep going. Another one was
maybe I would say sure. That I think that code. I don't think it was specific to OpenSea. The same logic has been used in many other places. Many other projects. I think it's a more a general issue across like multiple projects.
Yes. The standard implementation that first place I saw it was on the Merkle distributor for the Uni airdrop. But I know it's been used. Actually, I believe that it was used by Wyvern as way back in the day as well. Merkle roots, obviously a pretty common construction, and indeed protocol level construction as well. Where Seaport went wrong was removing that extra hash on the leaves, the data that goes into the leaves. Seaport 1.0, I should say. 1.1, of course, performs that extra check, which adds another 40, 45 gas, but we can live with that.
Okay. Wow. Let's open it up for some Q&A from the audience. I wish we could give a round of applause virtually here. I think there's a little heart button with a plus sign, and you can give a little round of applause for our guest today. And let's segue into Q&A. So for Q&A, yes, the round of applause are coming in. So for Q&A, just indicate by raising your hand, and we will try our best to at least get to one or two. And yeah, I want to say thank you on behalf of not only Spearbit, but as well as OpenSea, to everyone for joining this discussion today. And thank you to our guests as well. So let's get into some Q&A. To add, I think if you just raise your hand with the heart plus sign, and then we can give you the speaker role.
While we wait for that, I have a question for Zero H. So, Zero, I'm wondering from the OpenSea's perspective, and when you're talking with the organization there, how did you guys go about budgeting for security spend, and what were how did you convince OpenSea that, security was obviously as important as how much you guys have spent on it?
So I think the first thing is that OpenSea, the company, it's not a monolithic entity, right? There are a bunch of different perspectives um, and priorities that all get weighed against each other, and we all build consensus to the direction forward for our users and for the broader ecosystem. But the way that I personally think about this and tend to make the case for security spend is you can come at security spend from, all right, well, it's going to cost X. That X could be spent on something else, but instead it's going into this. And so it's weighing, well, we could have another full-time employee if we didn't do this particular security engagement, right? $1 million prize pool, that's money that could be spent on a lot of different things that would further various aims. But then on the flip side, you have to look at what are the odds that something really terrible happens, and what would the damage be, right? So it's really about avoiding an existential catastrophe for the ecosystem. When it came to Seaport in particular, even if the chance of something going really wrong was very small, the damage would have been absolutely massive. And so it was a much easier case to make. And as soon as it's put in that lens, then it becomes, in my mind, a justified expense. I will say that you do need to be careful when you're performing audits. I've been very impressed with the caliber of work that Spearbit has done. In case anyone's curious, we've been working with Spearbit directly, particularly after the Code Arena competition, and it became clear that they were up to the task of reviewing our code. But there are definitely, you got to be careful because you can burn through cash very quickly with audits, and so it's important to be discerning and to make sure. I think the most important thing of all is to have all of your ducks in a row before you even approach an auditor, both for the auditor's quality of life and for getting the most bang for your buck. Because if you deliver some half-baked code base that doesn't have sufficient tests, that's not well commented, that the auditor can't drop into and actually understand the code base quickly, then it's really not worthwhile for anyone involved. And there are better ways to. Basically, you should bring in an auditor once you're to the point where you feel personally and as a team that you're ready to go, and then they will disabuse you of that notion almost certainly, right? I mean, that's what you're looking for. It's what you're hoping for when you do an audit or run a competition, is that problems are going to be found. But at the same time, you just want to make sure that everything is ready to rock.
So we don't have any people raising their hand for Q&A. I assume that's because they're engulfed in the conversation with the current speakers. So I wanted to pass it over for one last question. I wanted to pass it over to either Alex or Hari to see if you guys have any questions you would like to ask Zero H.
This might be a long answer, but yeah, Zero Age. If there's anything, what would you have done differently with Seaport if you would change anything in the process? Anything on the code or anything on the security process Seaport has taken?
That's a really interesting question. In terms of the code base, there are already a number of things that we're putting finishing touches right now on a library for verification of orders. Seaport is pretty low level in that it's expressive, and there are ways to footgun yourself, particularly as a fulfiller, but also as an offerer. In general, the bias is to protect offerers and give offerers the tools they need, because the offerers are the ones that have funds at risk at rest, right? When you sign an order, then anyone can come and take that order and spend it, right? And buy your NFT or sell your NFT. But in terms of validating those orders, because it's so code optimized and gas optimized, there's an expectation that whoever is receiving those orders is going to be performing additional validation on top to make sure that it's not doing things like, oh, there's only offer items on this order and no consideration items, or vice versa, or that kind of thing. So Arya, who's on the call, is just putting the final touches on a really awesome Solidity contract that you can supply orders and it will validate them and give you a bunch of errors if you're doing things that are totally out of line, or warnings. Some of those orders that have really malicious behavior, we actually, I think, should have anticipated earlier on. And it took us running the code competition to really catch some of those things. Like, there should never be a native token that's being provided as an offer item that's being fulfilled using anything except for match orders, where you have to be explicit about every single thing, because otherwise you would be providing the ether as the fulfiller and then paying yourself. And so it's easier to get tricked or phished. So those checks we actually did include as part of Seaport 1.1, but there's a whole litany of additional, more high-level checks on royalties and a number of other things that are all bundled in this verification library. So keep an eye peeled for that. And I wish that we had basically created this library right from the get-go and not and been able to release it right away. That's, I think, the biggest thing that I would have done differently, is thinking through the practicalities of, okay, now I've created a listing or an offer, and is it safe? Can I fulfill it? Rather than abstracting that piece. But I'm excited for that to be hitting test nets and chains near you. It'll be deployed to every chain that Seaport is very soon.
Nice. And we do have 2 questions from the audience, so we'll go over by a little bit of time, if that's okay with all of the speakers. Iklos, I wanna hand it over to you to go ahead and ask your question.
Sure. Hi. Thank you for that. Zero Age, I had a question. So a bunch of audits have been done and a big one with Code for Arena. So what's the future outlook for Seaport in terms of security? down the line? And also, is there any plan for listing up on Immunify for bug bounties? Thank you.
Sure. Thanks for the questions. So going forward, right from the get-go, the idea with Seaport is that while OpenSea led the charge initially on putting it together and releasing Seaport 1.0, it immediately became a community-owned and maintained project with, I think we had 70 contributors by the time that we released Seaport 1.1. So it's very much a community-led thing at this stage, and we're exploring ways that we can improve formal verification, as well as just continue to expand our test suites and invariants so that we can continue to safely develop on Seaport. And for now, the focus is on deploying Seaport across every EVM compatible chain and ensuring that everything is all ready to rock there. But I imagine that as we move forward in the coming months, that we'll start to see more development effort into further optimizations, new features. There's a couple of really interesting directions that we're already discussing for Seaport 1.2 or 2.0. That being said, the current version of Seaport is entirely unowned, and anyone is welcome to just dive right in and start using it and doesn't need permission from anybody. And the contract is immutable. It's not going anywhere as long as the merge goes as according to plan, I guess. Maybe a bunch of state blows up September 15th. We'll see. But I'm highly confident that it's going to be there for the long haul. And so that's our security posture going forward. As far as the Immunify, there's always more you can be doing, and we're always interested to learn more about the different security offerings. That being said, OpenSea has a HackerOne set up with Seaport as one of the in-scope contracts with up to $3 million for a critical vulnerability that's reported. So that's our official channel for disclosing vulnerabilities, which serves a similar function.
Very cool. Thanks for that question, Niklas. And I'll hand it over to Rowan to ask the final question, then we'll wrap up.
Hey, yeah, thank you for having me. I have a small question, and it's more to the auditors. What is the approach you do, especially with those complex contracts? Are you testing functions, or what's the best way you try to do to get familiar with such a complex code base?
Gerard, would you be able to take that one?
What I did here, first you try to get like an overview of the code a little bit, and also make like a drawing, like Sawmon was telling, so see how all the contracts relate. And then afterwards I just start sort of at the top of the code and start reading it and trying to understand it. And then everything I don't understand, I just keep diving deeper until I understand it. Until in the end, you finally understand the entire code base. But with OpenSea, compared to the time, and there was not enough time to understand it 100% completely. So there, it was nice to be able to work in a team that different people could focus on different areas. And that you could rely on others to dive in other parts, and then you just select pieces of code where you dive into, and so that others don't have to dive into them. Anyone else to add something?
Thanks a lot, Gerard. It makes a lot of sense.
Okay.
Yeah, thanks for your question. And Moise, if you want to go ahead, we can wrap up the call.
Yes, just definitely want to give a compliment to you, Zero Age, as well. You're a wizard in this space, and you've been kind enough to, toss some compliments to not only the other guests from the Spearbit side and other security firms, and really share your knowledge. So thank you so much. And then for Sawmon and Natalie, thank you for also adding some great insight into your process. And to the Spearbit crew, I know you guys well, but really, really proud of you. And to all our guests, thank you for joining, and hopefully we have another one of these here soon. So stay tuned for that.
Thanks, everyone.